So this is a pretty straightforward unit, actually. And if you, yeah, if you get a couple of questions on the exam, they could be pretty easy marks. Because all we're doing is, like, we're taking functions, we're adding them together, we're subtracting them by each other, we're multiplying them, we're dividing them. And then we're going to do something in 10.3 a little bit different. But so, yeah, all your, and then we can do those algebraically and we can do them graphically. So, like I said, if we want to combine two functions and make a new function called f of x or h of x, we just add function f of x and g of x. The other type of notation you may see is this. It'll look like this. More often than not, it'll look like that. That just means add function f of x to g of x. And we'll see what that looks like in a second. Difference, if you want to create a new one, you just subtract them. Or the notation could look like this. F minus g of x. So here's an example. We got two functions. 2x plus 1 is f of x. X squared is g of x. You are asked to find the equation of the function f plus g of x. So all that means is you take function f of x, 2x plus 1, the whole thing. And you add the expression for function g. Can I combine anything here? Or do I have any like terms I can combine? No. So guess what my answer is? That's what it looks like when I add the two functions together. That's it. What's that? Oh, yeah, sure, you could. You don't have to. Here's a slightly different question. Oops, H of x. Actually, I'll do that. Just G of x. Oh, okay. You're asked to find the domain of this new function when you add them together. What would this look like if you graphed it? This should give you a hint, the squared. What kind of shape? What kind of shape does an x squared graph look like? Yeah, it's a U-shaped graph. Upside down or right side up. If there's no x squared, what's its shape look like? A line. Okay? So what's the domain of any parabola? Don't they go out both ways forever? Done. We can actually evaluate these new functions. What's the value of f plus g of -4? All that means is here's the function f plus g of x, right? Plug -4 in every time you see an x and calculate. So you just have to calculate that. So this gives me -8 plus 1 plus +16 gives me 9. That's how we add two functions together. How do we subtract two functions? Well, so h of x, or f minus g of x, we can call them either one, is equal to the function f. Remember, when you take these things, put each function in parentheses because it may change some signs. So function f is root x minus 1 minus function g, put that all together in parentheses because you see that's going to change the sign when we simplify. Well, when I take out the parentheses here, nothing happens. But what happens when I take out the parentheses from x minus 2? What does it become? Negative x plus 2. So watch out for that. Can I simplify anything? Is there anything that I can combine? Any x's? I can't combine these x's because this is in a square root. So I'm done. Now, this one, to find the domain, it might be a little hard because we haven't seen one that looks like this yet, have we? Okay, I mean, we've seen one that looks like that. It's that kind of shape. We've seen one that looks like that. It's a line. But what does it look like when we subtract one by the other? So here's how we can do it. What's the domain of f of x? What's the domain of just this one? Not starting at 0 because it moves 1 to the right. So it's 1 to positive infinity, right? Because this is, remember, it's the half curve, but this tells us it shifts 1 to the right, so it's going to look like that. So it's going to be from 1 to infinity. What's the domain of g of x? Well, if it just has an x in it, you guys, just remember, it's just a line. It's very simple. Okay, if it's got an x squared, it's a parabola. If it's got an x, it's just a line. So a line goes every direction forever. Okay. But what about this? This is whatever is common in both domains. Okay. What's in common in these two? Yeah, like this is everything. This is part of this, isn't it? So the only thing they would have in common is this. So we would say 1 to infinity. That's what they have in common. We can't say negative infinity to positive infinity because this doesn't include negative infinity up to 1. And again, you could be asked to evaluate. So just plug 0 into here and calculate. So f minus g of 0 is just going to be square root of 0 minus 1 minus 0 plus 2. It's just the pipes. Okay, somebody's trying to break out.
Oh, okay.
Yeah, school's locked down. Somebody's trying to escape. Can somebody tell me what the answer is?
Is that no solution?
Yeah, no solution. Because this is going to be 0 minus negative minus 1. We can't take the square root of negative 1. There's no solution. So you can see how we combine them or subtract them algebraically and how we can evaluate them. What about the graphs? We're given the graphs of two functions here. I don't know what their equations are, so I can't add them together. Okay? But what I can do is I can take points from each one and add them together. Let's start on the left. What's the x coordinate of these 2 points? -8. And remember, f plus g of x is the same as f of x plus g of x. Well, at -8, what's the y value of f of x? 2. What's the y value of g of x? -8. So I just do 2 plus -8. And that's the point I get when I add them together. -8 comma -6. So -8. When I add them together, I get that. Okay, next. What's the next x coordinate I have given? -4. So again, just do f of x plus g of x. So in f of x, what's the y value? 2 plus -8 again equals -6. So that's the coordinate. -4, -6. And those are obviously going to be connected. I just keep connecting as I go. Next one, x is at -2. What's f of x? 4 plus g of x. -4, which is 0. So -2, 0 is my next one. -2, 0. My next ones are at 0. Oops. 0. What's the value of f of x? 0. Plus the value of g of x? -6 gives me 0, -6. Equals 1.
Well, when x equals 1, I've got -2 plus -7 gives me -9. That's my 2 there. 1, -9. So I'm down there.
And I think we can see where this one's gonna go.
At x equals 4, I get -2 plus -7 again, which is -9. And I get this. So it comes down like that. So that's
The function of adding those two together. Okay. Subtracting
my graph.
and we'll finish this. What's different about this one? The two functions. They're not lined up perfectly, are they? Okay. We can only subtract the common parts. So how do you find the common parts?
Well, this doesn't exist on g of x, but this does. It starts, g of x starts here, right? So that means I've got to start my points there. G of x goes all the way out here, but f of x doesn't. F of x and g of x only go to here before one of them stops. So I have to do all the points between them only. Those are the only ones I can subtract, because this, way out at -9, 2, there's nothing to subtract here. So there's no point that exists. So I only do these ones. So I'm at x equals -5. What's the value of f of x? I'm going to do f of x minus g of x. 2 minus, be careful with this, -8, which becomes 10.
Right? Because it's 2 subtract -8. So you got to watch out for that.
So we get this, this, -5, -10 is all the way up here.
And then I do the same thing for the other points in between those barriers,
For lack of a better phrase. So x is 3, f of x is -1, minus g of x, which again is -8. That gives me 7. +1, pardon me, which gives me 9. Gives me 9. So 3, 9. 3, 9 is all the way up here. -3, 9. Next points of common are at 0, x equals 0. F of x is -2 minus g of x, which is -4, which gives me +2. So 0 and 2. And finally, x is 3. So at x equals 3, f of x is -2 again. Minus -3, we've got -7. Right? Yeah. That gives us 5. So we get 3, 2.
So it's gonna look like that. Very, very different looking. Okay.
And then the last question, again, I'm just sort of throwing examples at you that you can see. On quite a few of the provincial exams, there was a graphing one.
Okay.
The domain of one function f of x is everything less than -2. So remember, as integral notation, everything less than or equal to -2 is the same as this.
In interval.
G of x is every number greater than or equal to -7. So I start at -7 and I go up to infinity. State the domain of those two added together. Right. Everybody see how it's -7? I need to find what's in common. Okay. -7, but anything below -7 is not in this interval. So that basically takes this out. This is -7 is still in here. So is -6, -5, -4, -3, -2, -1, 0, 1, 2, but I can't go higher. I can go higher here, but I can't go higher than 2. So I can't go lower than -7 and higher than 2. So therefore, it's going to be from, sorry, -7 to 2. It's going to be like that. That's what's in common. Or, if you want to write it using set notation, either is correct. You don't have to know how to write both. You get that.